Good morning students, I am Kavita Monga, lecturer of physics from Government Polytechnic College Khuni Majra. Today we will study about lasers and its applications. Topics to be covered are, we will define what are lasers, basic concepts of laser, then components of laser, laser के क्या क्या parts होते हैं, then types of lasers, 2 level laser, 3 level laser and 4 level lasers. Solid state laser, उसका example we will study about ruby laser. Then gas laser, example is helium neon laser. Then what are liquid lasers, semiconductor laser, and finally few applications of lasers. So these topics we will cover today. To start with, the basic scientific principle behind a laser was first put forward by Dr. Charles H. Townes in 1954. The efforts of several scientists led to the development of first laser called pulse laser in 1960. So first laser was developed in 1960. Now laser stand for, L stand for light, A stand for amplification, S stand for stimulated, E stand for emission, and R stand for radiation. So full form of laser is light amplification by stimulated emission of radiation. Light amplification by stimulated emission of radiation. So this is what we mean by laser. So what is a laser? It is a device which produces a coherent beam of optical radiation by stimulated electronic, ionic or molecular transitions to higher energy levels. When they return to the lower energy level by stimulated emission, they emit energy. So laser is a source of light which is coherent. Coherent means all the waves they are in same phase. So this is a special type of light which have few characteristics. We will study about those characteristics. So this happens by stimulated emission of radiation. So what do we mean by stimulated emission? So there can be two types of emissions, spontaneous emission and stimulated emission. So let's see the difference. Spontaneous emission में जो light emit हो रही है, जो waves हैं या जो photons हैं, they can go in any direction. But in stimulated emissions, the emitted photons, they are in same direction and they are in phase. In phase means the crust fall over crust and the trough fall over trough. So this is the advantage of stimulated emission, that the emitted radiations or light rays or waves, they are coherent, means they are in same phase. So few terms, now we are going to define few terms which are related with this laser. What is absorption, what is spontaneous emission, what is stimulated emission, and then finally what do we mean by population inversion. So these terms now we are going to discuss. So absorption means energy is absorbed by an atom. The electrons are excited into vacant energy shells. So say this is, suppose this is the ground level of an atom, ये उसकी ground state है. By absorbing energy, the electron or the atom from the ground state, it can jump to the excited level. So E1 is ground state, E2 is first excited level say. Then by absorbing this photon h nu, the electron can jump from ground to excited state. So this, what do we mean by absorption? Absorption is by absorbing energy, the atom or electron can jump to higher level. So energy is absorbed by an atom, the electrons are excited into vacant energy shells. Now what do we mean by spontaneous emission? The atom decays from level 2 to level 1 through the emission of a photon with the energy h nu. It is completely a random process. So once E1 was the ground state, E2 was first excited level. So in the excited level, the atom cannot stay for long. It is unstable there. So it has to come down in its ground level. So when it jumps to ground level, the excess energy, जो energy है, it is released in the form of a photon. So it is completely a random process, it has to happen. So why? Because the atom or the electron, it cannot stay in its excited state for more than 10 raised to the power minus 8 second. So this was spontaneous emission. Now next, what is stimulated emission? Because in laser we are concerned with stimulated emission. So in stimulated emission, what happens? Atom in an upper energy level can be triggered or stimulated in phase by an incoming photon of a specific energy. So now here in stimulated emission, the atom which is in the higher excited level, it is stimulated or triggered to come down by an external photon, and then the emitted photon is also of same energy and it is in phase with the incident photon. So this is what we mean by stimulated emission, that this atom is de-excited in the presence of an external photon. So in this way, one, we get 2 photons, then these 2 photons will further de-excite or trigger 2, and then we will get 4 photons, and then 4 they will de-excite next 4, and in this way 8 and 16 and so on. So atoms in the upper energy level can be triggered or stimulated in phase by an incoming photon of a specific energy. So this is what we mean by stimulated emission. The stimulated photon have unique properties. Now why this is important to us? Because the stimulated photons, they have few unique properties. So they are in phase with the incident photon. जो incident photon से same phase में है, इसका मतलब है crust fall over crust and trough fall over trough. Same wavelength as the incident photon. So wavelength भी सबकी same है, frequency भी सबकी same है. So they are monochromatic. This property is called monochromatic. They travel in same direction as the incident photon. So all the photons, they are unidirectional, they travel in same direction. So they are in phase, they are monochromatic, they have same wavelength, same frequency, and they are moving in same direction. Now next, let's see what is energy level diagram. The possible energies which electron in an atom can have is depicted in an energy level diagram. So energy levels, different possible energy levels are there an atom can have. So energy level diagram depict that the possible energies which an electron can have. So these different colors, they represent different wavelengths and different frequencies of light. The possible energies which electron in an atom can have is depicted in an energy level diagram. So these say E1 level, E2 level, E3 level and E4 level. So they corresponds to different energy levels, or you can say what do we mean by shells, electronic shells. They have different energies, K shell, L shell, M shell and so on. Just like that, they have different energies. These levels, they also denote or represent different energies. So the electron can jump from E4 to E3, or it can jump from E4 to E2, or from E4 to E1. So in all these 3 cases, the photon which will be liberated, it will be of different wavelength and different energy. So different energies are possible. Waves of different wavelengths are possible. Now next, the operation of a laser, how a laser works, how it operates. In 1958, Charles Townes and Arthur Charloff theorized about the visible laser, an invention that would use infrared or visible spectrum light. So light amplification by stimulated emission of radiation. So LASCR, laser, stand for properties of laser. Laser, they are monochromatic source of light. Monochromatic means single wavelength, single frequency, and they are highly intense. Intensity is very high. Now the operation of a laser, a diagram, a figure is shown. This is a flash tube, partially mirrored surface, and this is fully mirrored surface, and these are atoms in between the tube. So the different steps in the operation of laser are, one is pumping the laser. So what do we mean by pumping? That is, we have to excite atoms from ground level to the higher energy shells. So this is what we mean by pumping the laser. So this is achieved by absorption. Atoms or electrons, they absorb energy and they jump to higher energy levels. So next is spontaneous emission. Spontaneous emission is always there, that is, once the atom is excited, it will not stay there for long, automatically it will come down to its ground level. So but in spontaneous emission, the emitted photons, they are not coherent, they are not monochromatic, they are not unidirectional, they move randomly in all possible directions. So they are of no use to us, so we are not concerned with spontaneous emission in laser. What we require is stimulated emission. So spontaneous emission, incoherent light and accidental direction. So emitted photons, they are incoherent, means they can move randomly and in any direction. So we are concerned with stimulated emission. Stimulated emission happen in the presence of an external photon. It triggers the de-excitation. So the emitted photon will be of same frequency, same wavelength, and they will be unidirectional and they will be coherent. So just see, incident photon, a single photon will trigger de-excitation, and what we will get? We will get a coherent beam. So crust fall over crust, trough fall over trough. This is what we mean by stimulated emission. So the light is coherent, it is polarized. The stimulated and emitted photon have the same frequency, same phase and same direction. So this is shown. Coherent means all these, they are walking in the same direction, uniformity is there, and this picture depicts the incoherent behavior. So in laser, what is required? Stimulated emission is required. Now what are laser fundamentals? The light emitted from a laser is monochromatic. It has to be monochromatic, that is, it is of one color or wavelength. In contrast, ordinary white light is a combination of many colors or wavelengths of light. So lasers are monochromatic. Laser emit light that is highly directional. That is, laser light is emitted as a relatively narrow beam in a specific direction. Ordinary light, such as from a light bulb, is emitted in many directions away from the source. So laser has to be directional. Then it has to be coherent. The light from a laser is said to be coherent, which means that the wavelength of the laser light is in phase in space and time. Ordinary light can be a mixture of many wavelengths. So these three properties of laser light are what can make it more hazardous than ordinary light. Laser light can deposit a lot of energy into a small area. So these are the properties why lasers are so harmful, because they can deposit a lot of energy within a small area. So monochromatic, coherent and directional. These are also, we say, these are the properties of a laser. Characteristics of a laser or properties of a laser: they are monochromatic, they are coherent, they are directional. Monochromatic, concentrate in a narrow range of wavelength, that is, it is of specific color. Coherent, all the emitted photons bear a constant phase relationship with each other in both time and space. So they are in same phase, crust fall over crust, trough fall over trough. Directional mean a very tight beam which is very strong and concentrated, they are moving in a single direction. So this incandescent versus laser light, what is the difference? So ordinary light, it has many wavelengths, multi-directional है, incoherent है, light from a bulb, while the laser light is monochromatic, it is directional, it is coherent. So what is the difference between a laser and an ordinary light? Many wavelengths, single wavelength. Monochromatic means single wavelength, single color, single frequency. Multi-directional, all directions are possible. Here unidirectional. It is incoherent, and later laser light is coherent. Coherent means all the waves they are in same phase. So now next is how to construct a laser. What are the requirements in the construction of a laser? So a pump source is required, a gain medium or a laser medium is required, then mirrors forming an optical resonators are required. So pump source, what will it do? It will excite the atom into its from ground to excited level. So just see common components of all lasers. So laser में क्या क्या component required होते हैं? Active medium is required. The active medium may be solid crystals such as ruby or niobium, YAG, liquid dyes, gases like CO2 or helium neon, or semiconductors such as gallium arsenide. So these are the materials which can act as active medium. Active medium contain atoms whose electrons may be excited to a metastable energy level by an energy source. So active medium is required because it contains the atoms which are to be excited. So next, excitation mechanism is required. How to excite the atoms from ground to excited state? So excitation mechanisms pump energy into the active medium by one or more of three basic methods. So three basic methods are optical, electrical or chemical. So by light energy we can excite the atoms, or giving electrical energy, or by chemical energy. So components required in lasers are active mediums are required, then excitation mechanism is required, and after that high reflectance mirror, a mirror which reflects essentially 100% of the laser light, and one is partially transmissive mirror, a mirror which reflects less than 100% of the laser light and transmit the remainder. So these were the components. Now what do we mean by population inversion? This is a term used popularly in laser. So population inversion, it is a state in which substance has been energized or excited to specific energy levels. So more atoms or molecules are in their higher excited state. So this state, when more number of atoms or molecules are in higher excited state, we said we have achieved population inversion. The process of producing a population inversion is called pumping. Now how to achieve population inversion is by the process of pumping. So examples, by lamps of appropriate intensity, by electrical discharge, and the third we talked about in the previous slide was by chemical energy also. So these are the methods of achieving population inversion, that is by pumping, and then further the pumping can be of three types. It can be optical, it can be electrical, it can be chemical. Now pump source, what does it does? It provides energy to the laser system. Pump source provides energy to the laser system. Examples, electrical discharges, flash lamps, arc lamps, and chemical reactions. So the type of pump source used depends upon the gain medium. So कौन सा एक्टिव मीडियम हम यूज़ कर रहे हैं, उसमें कौन सा सोर्स रिक्वायर्ड होगा. सो फॉर डिफरेंट एक्टिव मीडियम्स डिफरेंट टाइप ऑफ पम्प सोर्सेज आर required. So helium neon laser uses an electrical discharge in helium neon gas mixture. So helium neon laser में electrical discharge is used for providing energy. In excimer lasers we use chemical reactions. So a chart is given here, different types of pumping. This is the type of laser and this is the type of pumping used in that laser. So in ruby laser optical pumping is used. In helium neon laser electrical discharge is there. In semiconductor laser direct conversion is there. In CO2 carbon dioxide laser chemical reaction is used, while in gaseous ion laser electric discharge is used for pumping. So why pumping is done? This is to achieve population inversion. And what is population inversion? That a large number of atoms or molecules they are in their excited state. So this was the first requirement for laser, that large number of atoms must be in their excited state. So now what is gain medium? So major determining factor of wavelength of operation of the laser, excited by pump source to produce a population inversion. So gain medium is medium which contains the atom which are to be excited. So where spontaneous and stimulated emission of photons take place. So examples are solid, liquid, gas and semiconductor. So active medium or gain medium, it contains atoms to be excited. Optical resonator, two parallel mirrors placed around the gain medium. Light is reflected by the mirrors back into the medium and is amplified. The design and alignment of the mirrors with respect to the medium is crucial. Spinning mirrors, modulators, filters and absorbers may be added to produce a variety of effects on the laser outputs. Now next, what is lasing action? Means how laser is produced. What is lasing action? Energy is applied to a medium, raising electrons to an unstable energy level. So this is your absorption. ग्राउंड स्टेट से एटम्स को, एनर्जीज को एक्साइट किया जाता है. हाउ? बाय pumping and this is called population inversion. Then next, these atoms spontaneously decay to a relatively long lived lower energy metastable state. So spontaneous emission say they come to metastable state. Then a population inversion is achieved when the majority of atoms have reached this metastable state. Lasing action occurs when an electron spontaneously returns to its ground state and produces a photon. The partially reflected mirror allows the transmission of a small amount of coherent radiation that we absorb as the beam. Laser radiation will continue as long as energy is applied to the lasing medium. So now just see, now visualize this lasing action, what we have talked now. Till now, just see what is happening. So this is ground state. First atom will be excited from ground to excited level. So how it is done? This is done by giving energy. So this is called pumping. Pumping can be of three types. It can be optical, it can be chemical, it can be electrical. So now a large number of atoms, they are in their excited state. We say population inversion is there. They can't remain here for long, so they, by spontaneous emission, they come to metastable intermediate state. From ground to excited, there is intermediate state which is called metastable state. So by spontaneous emission, they come to metastable state, and in this level between metastable and ground state, the laser is produced. So one incident level, one which is called stimulated emission, incident laser beam one light, it will trigger one atom or electron to de-excite from metastable state to ground state, and the laser light will be coherent. Coherent means crust will fall over crust, trough will be fall over trough. So this stimulated emission of radiation occur between these. So this is what we say, this is lasing action. And how laser is produced. So again more elaborately it is shown here. So this is lasing medium. Medium है जिसमें atoms हैं which will be excited. So they are at their ground state. Pumping is done by either electrical pumping or optical pumping or chemical pumping. Pumping means giving energy. So by giving energy, they will absorb energy and they will be excited. They will go to their excited level. So this is functioning of a laser is shown. So this is high reflector mirror here, one side. Second side pe, this is partially reflecting. This is output coupler. This is high reflector. Totally reflecting, partially reflecting mirrors are there. So this is the medium. Medium it is ground state में है. Pumping is achieved by giving energy in any form, electrical, optical, chemical. After that, lasing action यहाँ पे start है. Spontaneous emission, start of stimulated emission. So gray it shows ground level. Pink color shows first energy level. Blue color shows second. Green spontaneous emission and yellow stimulated emission. The gray atoms, ions or molecules depending on lasing medium. So now just see what is happening in step 3. This production of laser is beginning, laser action is beginning, that is stimulated emission is has started. So 1 से 2, 2 से 4, 4 से 8. So just see here, then after reflection from this mirror, so stimulated emission is building up, and full stimulated emission coherent laser beam generated. So here the laser beam is generated. So this is basic laser operation. Now next let's start with different types of lasers. What are different types of laser? So lasers can be classified in different manner. So laser are of following type. They can be classified on the basis of state of active medium. That means on the type of medium, gain medium, active medium we are using, we can classify the laser. It can be a gas laser. Agar medium is gas, then it will be gas laser. If medium is semiconductor, it will be semiconductor laser. If medium is a solid, then it will be a solid state laser. So that means according to the medium used, active medium or gain medium, we can classify laser as gas laser, solid state laser or semiconductor laser. Similarly, on the level of transitions, we can classify laser as 2-level laser, 3-level laser or 4-level laser. Another way of classifying the lasers is on the basis of output we get. So output we can get pulse laser or continuous wave laser. So there are different ways in which lasers can be classified. So first, on the basis of output, the laser can be a continuous one, it can be a pulsed one. That means we are getting pulses of energy. So this energy versus time, this is graph for a continuous wave and this is for a pulsed output. So according to the active material, it can be solid state, liquid, gas, excimer or semiconductor laser. According to wavelength also, wavelength means laser किस light का है, it is of infrared light, it is of visible light, it is of ultraviolet light or it is of X-rays. Since laser is of single frequency, single wavelength, so we can have different lasers depending upon the wavelength. It can be of infrared light, it can be visible light. Visible maybe there are 7 colors, VIB, GYOR. So it can be of ultraviolet light, it can be of X-rays. So now what are 2-level lasers? 2-level lasers means we will use only 2 energy levels to produce a laser. So unimaginable, as absorption and stimulated process neutralize one another. So the material becomes transparent. So these are not very popular lasers, 2-level lasers, because absorption and stimulated process neutralize each other. So this picture, it shows a 2-level laser. So what will happen, just see here, absorption will be between E1 and E2. First atoms will jump from this ground to excited level, then spontaneous emission will be again in E2 and E1, and stimulated emission is also between E2 and E1. So now this is a 3-level laser. Here 3 energy levels are used. So ground state, this middle one is metastable level and this is the highly excited level. So excitation is between this first and third one. That means by absorptions atoms jump from ground to this excited level. Then by spontaneous emission they come to metastable level, and this lasing action, this occurs between metastable state and ground state. That means the laser produced is between these 2 energy levels. So initially excited to a short-lived high energy state, then quickly decay to the intermediate metastable state. Population inversion is created between lower ground state and a higher energy metastable state. So the laser is produced between these 2 energy levels. So this is how a 3-level laser works. 3-level laser again. So this is for niobium YAG laser and this is for, these are parameters for this laser and these are for helium neon laser. So lambda 1, lambda 2, lambda 3, all the 3 wavelengths are shown. This is lambda 1, this is lambda 2 and this is lambda 3. That means the wave that will be required for pumping. This will be of lambda 1 wavelength. The wave which will emit from spontaneous emission, that will be of lambda 2 wavelength, and the laser will be of lambda 3 wavelength. So 3 level laser, step 1 is pumping from first to third level, then spontaneous emission is from third to second